Number 49. Two discs are mounted on a low friction bearing on a same axle and can be brought together so that they couple and rotate as one unit. First of all, let's we draw the diagram for these three lines. So what is given in these three lines? You have two discs and these two discs are mounted on the same axle. So let's we take this axle. I have two discs, disc 1 and then disc 2. These two discs are rotating on a same axle. And then what they did, they brought together and then by that they couple together and to rotate as a one unit. So after some time what happened, these two discs couple, that means it's joined together and to make as one unit. That means what happened here, the disc 1 and disc 2 joined together and then it's rotated as a single unit. And then they give few more information. The first disc with rotational inertia 3.3 kilogram meter square. So let's we take, this is our disc 1, this is disc 2. Clear? And the first disc rotational inertia, that means I1 value is given. What's that value? 3.30 kilogram meter square. And it is rotating counterclockwise. That means it is rotating counterclockwise. The first disc is rotating in the counterclockwise. By that, its initial angular speed is given, which is omega I value, which is 450 revolution per minute. And then the second disc with the initial with a rotational inertia 6.6 kilogram meter square. So that means the second disc rotational inertia I2 value is given, which is 6.60 kilogram meter square, and this is also spinning counterclockwise direction. By that it takes, which is omega, this is omega 1I and this is omega 2I. So what's the value? Which is 900 revolution per minute. Now by using these information we have to find the answer for part A, B and C. So let's read what is in the first question. What is their angular speed after coupling? So now you can see initially these two discs are separated, right, on the same axle, and then what happened after that, they join together. You can see the first disc is rotating in the counterclockwise direction, the second disc is also rotating in the counterclockwise direction. So when these two discs are joined together, what will happen? Both discs will be rotating in the counterclockwise direction. That means your omega final value will be in the counterclockwise direction. What we studied in the theory, if the disc is rotating in the counterclockwise direction, it will take the positive value. If it is rotating the clockwise direction, it takes the value of negative. So you should be very, very careful about the sign. So why I just mentioned the final after it coupling together, why it is moving in the counterclockwise direction. You can see the first disc is also counterclockwise, the second also the same. So when these two join together, what will happen? Both will join together and it will be moving on the same direction. Now what we have to do, after it coupled together, we have to find what is its value for omega final. That means the angular speed final we have to find. For finding this answer, what we have to do, we have to use the conservation principle. That means the law of conservation of angular momentum we have to use. What is that rule? Li, which is equal to Lf. So let's we take these are Li, this is our Lf. And we studied the formula for angular momentum L, which is equal to I omega. So what I have to do, I have to apply this rule for the first disc and second disc, and then I have to use the same rule for the final stage. So this is our initial and final. So better I can write here. This is our initial, this is final. So I have to apply this rule for both diagram. So let's we apply the rule. So I'm going to apply this rule for the first one. So for the first disc, if I apply this rule, how can I write? I can write I1 omega 1I plus, and then I have to use this one for the second one, I2 omega 2I, which is equal to, now what happened? These two discs coupled together, they clearly given in the question. So I have to apply this rule. How can I write? I1, because both discs join together. So I1 plus I2 multiply by, and both this join together, and it is rotating the counterclockwise direction. So which is nothing but omega final, because now these act as a single unit. So that's the reason I just write omega final. Clear? Now we have to find the value for the angular speed final. So I have to rearrange this rule. So how can I write this one? Therefore, omega final, which is equal to I1 omega 1 initial plus I2 omega 2 initial divided by I1 plus I2. Now I am going to substitute the value here. The first disk rotational inertia value is 3.3 multiply with the initial angular speed. I think it is 450, right? See, 450. Second disk is 900 and its moment of inertia value is 6.6. So I can substitute the value directly here. So 3.3 I1 multiply by 450 plus I2 value 6.6 multiply by 900 divided by 3.3 plus 6.6. Let's see what is the answer for this. 3.3 multiply 450 plus 6.6 multiply 900 divided by 3.3 multiply 6.6. I got the answer here as 3 points plus. I got the answer here as 750. So the answer for omega the final angular speed omega f, which is equal to 750 revolution per minute. I did not convert this revolution in terms of radian. I did not convert the minute in terms of second. So I can just leave as it is. If in the exam, if they ask you to convert, you have to convert. So right now I'm going to leave this omega f in terms of revolution per minute. So the answer for the first part, which is 750 revolution per minute. Still, we have two more parts. Let's just go back to the question, and we have to read what is given in the second part. What is given in the second part? If instead the second disk is spinning clockwise at 900 revolution per minute, what is their angular speed? So I can draw the diagram one more time here. So in the second part, what they say, you have two disks, right? Disk 1, disk 2, and then what happened? Both disks coupled together, right? So this time what they said, initially they mentioned the first disk is rotating in the counterclockwise direction, and the second disk also moving the counterclockwise direction. But what small change they did in the second part, they said the second disk now which direction it is rotating? Clockwise direction. Same number, which is 900 revolution per minute, and this one is 450 as it is. Clear? Now they ask, after it coupled together, what will be its value of angular speed? That means again we have to find omega final. But the most important thing, we have to be very careful about the sign. You can see if the object is rotating in the counterclockwise direction, it will be positive. If it is moving in the clockwise direction, it will be negative. So now you can see your first disk have the rotation of 450 revolution per minute, but the second disk is more than the first one. So after it coupled together, what will happen? The greater will it will change the direction. So now you can see the second disk is 900. So what will happen after these two disks will join together? What will happen? Both disks will be rotating in the clockwise direction. Why it is clockwise direction? You can see the second disk has this value of omega 2 initial is 900 revolution, but here it is moving in the clockwise direction. That's the reason the greater value will take advantage. Clear? Now again I'm going to use the same formula. What is that formula? I can write I1 omega 1i plus I2 omega 2i, which is equal to I1 plus I2. Same rule I'm writing here, but this time a small change because your second disk is moving in the counterclockwise direction. So what we have to do, we have to use the minus sign here. Why? Because the second disk is rotating in the clockwise direction. That's the reason I have to use minus. Now I am going to rearrange this equation in terms of omega f. So the final angular speed, which is equal to I1 omega 1I minus into plus minus, so better I can write this one, I2 omega 2I divided by I1 plus I2. Let's we substitute the value here and we can see what will be the answer for that. So I1 value is 3.3 multiplied by 450 minus of 6.6 multiplied by 900 divided by 3.3 plus 6.6. So let's see what is the answer. The answer here is minus 450. So omega final right now is minus 450 revolution per minute. This is the answer for part B. And now we have to give the answer for part C. What they said, which direction? So they are asking about the direction after it couples together. So this direction is for the second part. So what they have, what they gave here, if instead the second disk is set spinning clockwise direction, what will be the direction? It's very easy. You can see the second disk is rotating the clockwise direction, which takes the value of minus 900 value, right? So what will be the direction? Final answer for the second part, we got the negative answer, right? What is the answer for the second part? We got negative value. So which direction the disk will be rotating? Which is clockwise direction. So the answer for the third part, the negative sign in part B, the negative sign in part B indicates the final angular speed is in clockwise direction. Clear? Why it is clockwise direction? Because the direction of the second disk initial angular speed, that's very, very important, because the second disk angular speed is greater. So that will make, after it coupled together, what happened? The answer for the angular speed, we got minus 450. So the answer for the third part, the direction indicates, so the negative value of the part B answer indicates the final angular speed is in the clockwise direction. So this is the answer for the third part. That's it. Thank you.